Hello students. In the last experiment, we had seen the preparation of M/50 solution of oxalic acid. And using that solution, today we'll be finding out the molarity and strength of the given KMnO4 solution. So experiment number 4, aim of the experiment is prepare M/50 solution of oxalic acid, and using this solution find out the molarity and strength of the given KMnO4 solution. You will write this on today's date, that is 6/5/2020. After aim of the experiment, you will write theory. Theory will include chemical equations, two chemical equations. One is molecular equation and the second one is ionic equations. So molecular equations, you see the overall molecular equations. 2 moles of KMnO4 reacts with 5 moles of oxalic acid in presence of dilute H2SO4, resulting in the formation of potassium sulfate plus manganese sulfate plus water plus carbon dioxide. And the ionic equations, see the overall ionic equations, it is 2MnO4 minus plus 16H plus 5C2O4 2 minus gives Mn in plus 2 state plus 8H2O plus 10 moles of carbon dioxide. This is also a redox titration, and you will copy down these equations which I had provided you here with. Then the experiment, what is the experiment you will do? This is the experiment you will be doing. You see this is the burette. It is clamped on the stand and it is filled with KMnO4 solution, potassium permanganate solution. It is filled in. And this is 0 ml. The capacity of this burette is 50 ml. This is your titration flask, and we will transfer 10 milliliter of oxalic acid solution with the help of a pipette into this titration flask. Okay, then we will add 1 test tube full of dilute H2SO4 to that of this titration flask. 1 test tube is 20 milliliter. So you will add 20 milliliter of dilute H2SO4 into this titration flask, which contains 10 milliliter of oxalic acid solution. Then we'll heat the contents of this titration flask to 50 to 60 degrees Celsius. How will you know that it is 50 to 60 degrees Celsius hot? You will put your palm underneath the conical flask and you will check whether your palm is able to resist that heat or not. So you will heat to that temperature, and in the hot condition only you will start with that of the titration. So you see, you have started with the titration. This was oxalic acid solution that was colorless. Dropwise will start the titration, and you will see that there will be a change in color after the reaction is complete. And what is the change in color? It is colorless to light pink color. So that is the end point. So end point is the point where the reaction is complete. So you will note down that in the observation table where the reaction got completed. And the reaction got completed when the solution turned from colorless to that of light pink color. So this is the experiment you will be doing in hot condition. Oxalic acids titrations are to be done in hot condition. This is a redox titration. So titration is to find out the strength of an unknown solution. So the unknown solution that is provided to you here is KMnO4 solution. And the known solution is that of the oxalic acid. Its concentration is known to us. Its concentration is about M/50. So we'll start with the titration and we'll take 3 observations there. Before you take the observations, you will write the indicator. KMnO4 is a self-indicator. Then you will write endpoint. Endpoint is colorless to permanent pink color. Then you will write observations. Weight of oxalic acid taken equals to 1.26 grams. Volume of oxalic acid solution prepared equals to 500 milliliter. Molarity of oxalic acid solution equals to m by 50. We know its concentration, it is m by 50. Volume of oxalic acid solution taken for each titration is equal to 10 milliliter. You will transfer with that of pipette to that of the titration flask. Then you will make an observation table which will include serial number, initial reading of the burette in milliliter, final reading of the burette in milliliter, that is the unit, and volume of KMnO4 solution used in milliliter. So suppose the first observation, usually we start from 0, that is 0.0. You will report to 1 decimal place, and you got your endpoint final reading of the burette at 10.1. So the difference in the two, that is final minus initial reading, gives you the volume of KMnO4 solution used. So volume of KMnO4 solution used in the first observation is 10.1 milliliter. Then second observation you will note down, the final reading of the burette becomes the initial reading of the burette in the second observation. So final reading in the first observation was 10.1. So we'll start with 10.1 for the second observation, and suppose final reading of the burette comes out to be 20.1. The difference in the two that gives you the volume of KMnO4 solution used, and the difference comes out to be here 10.0 milliliter. The second final reading of the second observation becomes the initial reading of the third observation. So initial reading will start from 20.1, and suppose the reaction gets completed, you get the endpoint at 30.1 suppose. Then the difference in the two gives you the value of volume of KMnO4 solution used. So it comes out to be 10.0 milliliter. 30.1 minus 20.1 gives you 10.0 milliliter. You will write below the table concordant volume. Concordant volume is here equal to 10.0 milliliter. Concordant volume is not the average of all the three readings. It is two same readings you should get. So two same readings you have got. It is 10.0 in the second and 10.0 also in the third reading. That becomes your concordant volume. So the concordant volume here comes out to be 10.0 milliliter. I hope observation table is clear. Then we'll go for calculations. We'll calculate two things here. Molarity of KMnO4 solution, and first one, and the second one is strength of the given KMnO4 solution. So you see how I calculate molarity of the given KMnO4 solution. I showed you there in the theory, the equation from the overall balanced chemical equation. It is clear that 2 moles of KMnO4 reacts with 5 moles of oxalic acid. Therefore, M into V of KMnO4 divided by M into V of oxalic acid is equal to 2 upon 5. This is the formula, 2 upon 5, where M of KMnO4 is the molarity of KMnO4 solution, V of KMnO4 is the volume of KMnO4 solution, M of oxalic acid is molarity of oxalic acid solution, and V of oxalic acid is volume of oxalic acid solution. So we'll calculate molarity of KMnO4 into concordant volume. Concordant volume we just wrote below the table, divided by 0.02. 0.02 is the molarity of oxalic acid, M by 50. So 1 by 50, the value comes out to be 0.02 into volume of oxalic acid, which we took with the pipette, it is 10 milliliter, equals 2 upon 5. So we'll put the values, M of KMnO4 into concordant volume, we got it as 10 milliliter divided by 0.02 molar into 10 milliliter equals to 2 upon 5. Therefore, molarity of KMnO4 on calculation comes out to be 0.008 molar. So that is the molarity of KMnO4 solution that is provided with 0.008 molar. We then calculate the second calculation, that is strength of the given KMnO4 solution. So strength is always calculated in grams per liter. So strength in grams per liter equals to molarity into molecular mass. Molecular mass of KMnO4. So molarity just now we calculated, it came out to be 0.008 moles per liter into molecular mass of KMnO4 is 158 grams per mole, which on calculation gives you the value 1.26 grams per liter. So two things we have calculated. We'll report the result at the last. The result is molarity of the given KMnO4 solution is equal to 0.008 molar, and strength of the given KMnO4 solution is equal to 1.26 grams per liter. So till here you will write, you will note down in your practical notebooks, and after the school reopens, we'll do the experiment on this. Yes, here's a quote for you students. You are braver than you believe and stronger than you seem and smarter than you think. All our dreams can come true if we have the courage to pursue them. Stay home, stay safe, children. Thank you so much. Thanks a lot.